Welcome back for another video. In this one, we are looking at that place value anchor piece. This is one of my favorite pieces, but it's also one of the toughest ones to construct in my experience. So I would strongly encourage you to watch the assembly video before you watch this particular video. And that way you will understand where these pieces fit. Definitely watch the assembly one first. But this is a math skill, so I'm in my math notebook, and I'm using pages 7 and 8 for this one. For me, my anchor piece always goes on the right, so I'm using page 8 for that, and then practice on page 7. So rather than make us all seasick, I'm just going to jump to those pages. And you can see that I would glue down my pocket to hold that place value line once we're finished and it's folded. I would give this page a title, and then we will come back to these forms in just a minute. So you get the pieces from me that look like this. You will want to cut these apart. This will make 9 of those little doors. And then you have 9 little doors here. So a total of 18 of those little doors. The decimal places are green. You get a decimal and 2 commas. And then I used yellow for the units period, blue for the thousands period, and orange for the millions period, because I wanted students to see that distinction between those. And of course, eventually you'll see that there's a comma between each of these color designations. The colors were just arbitrary, but the idea of the color will help scaffold this whole concept of this place value line. I also want them to see the pattern of 1, 10, 100 that repeats in each of the periods. So once you cut out all those little doors, would not glue them down yet. Just get them cut out, and then I'll show you how I would proceed. You will need one of your little doors. This is the outside. I did not take the time to do all of them because it would take forever on this thing. But this is the outside when the little door is folded. So this is the one that will fit in the ones place. Then for the inside, this is where you will have to decide how far ahead, how basic or advanced you want this to be. I was using it for very advanced students, so I'm going to go ahead and give them all 4 forms. Now for these particular examples, I'm going to use a 1 as my digit in each place. I'm trying to show them how the one's value changes based upon the seat that it's in. So my numbers will all be bases of 1, but the places will change based on the number of zeros, based on the position of that 1 in this number line. So for right now, expanded is not very exciting, but when we get back over to our practice, it will become more so. Okay, so starting with this one, the outside says 1. So the standard is just the number 1. Now you can use the number 1 with serif. I prefer not to. For my dyslexic mind, it's much better to use this one. Okay. Another suggestion that you might want to consider here is to do each of these in a different color. So do all your standards in one color. I would not do that here because we're almost getting into too many colors, but you could do it how you want to. For word form, this is just the correct spelling of the number 1. If you were working with beginning students, you might want to contrast that to this word. I was working with advanced students, so this was not necessary for my students. But again, you decide how much of this you want to show them. Expanded for the moment will be the same as standard. And then scientific. This is the one that may be a little bit more than you want to do. But if you want to show them, this would be 1 times 10 to the 0 power. Anything to the 0 power is equal to 1. So 1 times 1 is 1. If you want to go into scientific notation. Okay, moving to the next one. I'm going to do all of my whole numbers and then we'll get into the decimals. My next one, my next little door would be the 10. So the standard form is the number. For now, that will also be expanded form. The word is 10. Again, you could contrast that to this word. If you live in the South, we tend to pronounce those very much the same. But again, my students did not need the language. They just needed the math. So this one, I'm still using 1 as my base number, but this is 10 to the first power. 10 to the first power, that is 1 0. And 1 times 10 is, of course, 10. But if you're teaching the scientific notation, I would start right here and help them realize that that 1 corresponds to 1 0 right there. 10 to the first power. You could even write that out depending on how much your students need. If they've never seen this before, I would definitely consider doing that so that they learn to read those powers. Okay, moving on to the next place. I have, again, this is the inside of the little door that's marked 100. So 100 is the standard. Now this time we have the 1, but we also have 100. So this is a 2-word word form. Expanded will be the same, and this is going to be 1, that's that base number that I'm using every time, times 10 to the second power, and that means 2 zeros. So help them make the connection between this power and these zeros. Okay. You could also read that as 1 times 10 squared. All right, moving on. I'm going to try to put a couple more right here. And the next one is moving us, actually, that is not the next one. The next one is going to be a comma. So let me show you how I would do the comma. If you have, just take your comma and open the door. I would just tell them that this is the word comma. Please do not let them write coma. Take the time to explain comma. First time I did it, I would go through this with them because I see it too many times as a coma. That bugs me. Comma. This is 2 syllables. Comma, comma. As opposed to coma, comma. Comma, coma. The one we want is the first one, so not this one. Coma, the second one, is the state of unconsciousness. Comma is a punctuation mark. It is used to separate numerical periods, and a period is defined as a 1, 10, 100. So every time you have a 1, 10, 100, you will put a comma. So make sure they understand about commas. These are every 3 digits. Actually, let's not say digits. Let's say every 3 places on the whole number side, you will use a comma. So a large number can have many commas. Many commas, let's just say as many commas as needed. As opposed to a decimal, which can only be in there once. So the purpose of the comma is to separate the numerical periods, the place values every 3 places. You will put a comma and you can use as many as needed. I think it's only necessary to explain this once, so you don't have to write this again. But since we are moving into our thousands period, you want to show them that comma sits in there. The comma helps my eye to know where I am in the number. It is not mathematically necessary. Another thing I would tell them here, calculators do not have commas, generally. So you won't push a comma on a calculator. You will push a decimal. But I've had students to push the decimal every time they see a comma. So make sure that they know the difference there. Okay, so the word form here is 1, and the period name is 1,000. And expanded, in this case, is going to look just like standard. Scientific will be 1, that's our base number, times 10 to the 3rd power, or 10 cubed. So you put your 1 down and then 3 zeros. This 3 corresponds to those 3 zeros. And with scientific, I leave out the comma. That's just a habit of a lifetime, but you can certainly put it in there if you want. Okay, at this point, I would go ahead and glue these down onto the frame. I would start with the 1s. Sorry, I wanted laser. I would start with the 1s, stick it down, close the door and glue it down. Then the 10s, then the 100s, then the comma, and then the 1000s. Call their attention to the color change. We're moving from the yellow period into the blue period, and that's where that comma will divide. And then moving on to the 10,000s, not thousandth, 1,000. It's time to start calling their attention to the D or the TH. So this is 10,000 because we just did 1,000. So 10,000. Expanded will be the same. And then scientific is 1 times 10 to the 4th. So I have that 1 and then 1, 2, 3, 4 zeros. That 4 zeros corresponds to that 4 in the exponent. And hopefully by this point they're starting to get the hang of the scientific. Okay, so standard for 100, and here comes the period name, 1,000. So here I'm combining a 1, 100, and then the period name of 1,000. So it's important to know how to spell those words. 100,000. Expanded will look just the same in this case. And then 1 times 10 to the 5th power, or 1 and 5 zeros. You are laying some serious science foundation here if they understand scientific notation. Okay. And then let's put in another comma. So you'll need to put in another comma as you're gluing it down, because we're moving into that orange period that begins with 1, and then the period name is million. So your word form is 1 million. Your expanded form will look just the same as standard for right now. And then this will be 1 times 10 to the 6th power. That is a 1 with 6 zeros. Okay. The middle place in the orange period is going to be your 10 millions place. 10 is always in the middle. So 10, there's 10,000, 10 million, 10 million, and expanded will be the same as standard for now. Then 1 times 10 to the 7th power is a 1 and 7 zeros. Once the numbers get this big, it's probably a good idea to use the commas, because that helps the eye to stay organized. And then finally, we have 100 million. Don't lose the 1, because if you just say 100 million, that can get a little tricky. So it is 1. That's going to be, 1. Boy, I'm losing it on this one, aren't I? 100. Here's 100,000. We need 100 million. So this is 100 million. At this point, I would pull in some real life examples, like the national debt, or the distance from the sun to the earth, with some large numbers. Scientific form will be that 1 times 10 to the what value at this point. You count those zeros. So this is 8th power. 1, 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros to correspond to that exponent of 8. And I stopped there. I thought about going on to billions, but I thought that might be pushing it just a little bit. But that takes care of my whole numbers section. Now, it is time to put in my decimals section. So we need to actually define the decimal point. Let's talk about what a decimal point really is. And so instead of a comma here, let me erase the text. I want to talk to my students about a decimal point. Let's start with the purpose of a decimal. Decimal. Its purpose is to separate whole numbers from parts. So I would probably go ahead and write this. Whole part. And a part can also be called a fraction. So the purpose of that decimal point is to separate the whole numbers from the fraction part. You could also tell them that a number can only have one decimal. Unlike commas, you can only have one decimal in a number because there's only one place where you need to separate the whole numbers from the parts. And I would give them an example right here. I would use $10. This is an example most people can relate to. So on this side, you have the whole dollars. And on this part, you have the cents. And the decimal separates those two. It exists for the purpose of taking the whole numbers to one side and the parts to another side. So make sure they understand what that decimal is and then glue it down. And I think I'm out of paper, so let me get a copy of this one. If that's, yes, that'll work fine. Let me make a copy so I don't lose my original. I learned that the hard way. And then let me bring this one right in here. Okay, we're ready to start into those decimal places at this point. So let me close that out. Oops, forgot that. Bear with me 1 second. Let me get my... I spent a whole week on this lesson with my students. I think I saw them 3 days in the week. So we spent our whole week of math time really drilling into this. And I think it was time well spent. They needed this anchor to be able to understand place value and also some dosage stuff that we had to do as well. So you can spend as little time or as much time. This is a tough anchor piece to construct, so I would definitely make it worthwhile. Okay, so for this one, we are going to go with a decimal, and we're going to look at the place to the right of that decimal. Now, I encourage students to use this 0. I always called it a ghost 0 with my students because it could float in there. It can float away. It doesn't change the value of the number. But I like it because it helps me not miss the decimal. Okay, so you will see me use the leader 0. Now, in my particular objective for making this piece, the nursing students had to use that leader 0. So for them, it was not an option. And in that case, I didn't make it dotted because their program insisted that they use it. But you can certainly make it a ghost if you want to, or you can make it a solid 0. Okay, the word form for this. I have a 1 that I see there. And that first place to the right of the decimal is called the 10th. And you want to make a very big deal about the th on the end. I can't pronounce that very well, but make sure you call your attention to that for your students, because that tells me that this is not the tens place. This is the place after the decimal. So if I'm seeing that TH, it means it's after or to the right of a decimal. Okay. Expanded form, again, is this one. Now, there is another way to write 1/10. I would go ahead here and teach them that way as well. I think I would put it right here. There is the fraction form for a 1/10. It can be written like this. Okay. The scientific, if you want to go this far, it is 1 times 10 to the negative 1 power, because it is 1/10. That's the better place to put the fraction form for me. When you have a fraction, you are going to have a negative exponent. That fraction bar equates essentially to that negative exponent. Okay, moving on, I would glue that one down, and then let's go ahead. Let me erase this and copy it, and I won't have to keep doing that. If you feel like they're getting confused, I would stop. It is far more important for them to understand than to fill this all up at one time. Okay, standard looks like this. So I have a 1. It is 2 places after the decimal, so that is hundredth. Not hundredths, because 1 is singular. Again, I would call their attention. I would have them to highlight that TH. Expanded, right now, looks just the same. Scientific, let me think about the fraction here. That's 1/100th. So that's 1 times 10 to the negative, because I have that fraction bar, and there are 2 zeros down there. So that is a -2. That -2 matches up to this bar and those 2 zeros. There's the bar and 2 zeros. Up here, there was the bar and 1 zero, the bar and 1 zero. So that pattern continues, but help them to see the fraction, and that will help. Okay, then we have a standard form that looks like this. So I have a 1. It's 3 places out. That is 1,000th, not thousand, thousandth. Make a big deal out of that. And expanded, for the moment, is still this one. The fraction looks like this. So this is 1 times 10. There's my bar and 3 zeros. My bar and 3 zeros. We're almost there. Go ahead and glue that one down. And then we have standard is 0, 0, 0, 1. expanded will also be. You could also jump down here and have them to write the fraction. You've got 4 places in that decimal, so that'll be 4 zeros down here. And in word form, this is a 1 in the 10,000th seat. One 10,000th. So this will be 1 times 10 to the negative. Count those zeros. There's the bar and 4 zeros, so that is a negative 4. Okay. And then we have standard. One, 2, 3, 4, 5 decimal places. I promise expanded's coming. Right now it seems very redundant, but it's coming. Okay, and this is a 1 in the 100,000th place. You don't have a 1ths place. You start with tenths. That's a little tricky too for some students. So 1 in the 100,000th place. There's that TH that tells me this is a fraction. 100,000th is my denominator, a 1 here. So this is 1 times 10. We know it's negative because we have that bar. This is a fraction, and there are 5 of those. So 10 to the negative 5th power. All right, one more. Standard is pretty rough on the eyes. You have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So this is 1 in the millionth seat. TH, millionth. That tells me that I'm dealing with a fraction that has a million on the bottom, a 1 on the top. So this is 1 times 10. Count your zeros. There are 6 of them. There's the bar. So this will be a negative 6 power. And expanded is just the same. Glue those down. So now your students have an interactive line of place values with the correct punctuation. I'm going to stop this video because it's very long, and then in the next one I will show you some practice that I used with my students. It should be a much shorter video.